In section 10.2, we're going to discuss a series. A series is the sum of the elements in a sequence. So if we have this given sequence, 7, 10, 13, and 16, the series corresponding to this sequence is 7 plus 10 plus 13 plus 16, which is 46. An arithmetic series corresponds to the sequence. So an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. The series we write like this. S sub n corresponds to the sum of the first n terms of a sequence. It is n times the first term plus the last term divided by 2. Now, we can plug this top formula in for a sub n and get another formula. So an alternate formula for the sum of a series is n over 2 times 2 a sub 1 plus n minus 1 times d. Both of these formulas can be used to find the sum of an arithmetic series. So let's take a look at this example. Find the sum of the first 27 terms of the sequence. So first we need to find, well, what are we given? We know the first term. We know that this term, or this sequence, has 27 terms, but we don't know the last term in the sum. We can, however, figure out the difference and use this second formula. So let's do it that way. So the sum, well, first let's find d. So to find d, we need to take two consecutive terms and subtract them. Now, just to be certain, because they didn't tell us if this is an arithmetic or geometric series, let's take these consecutive terms. Oops, this is negative 7. And so 2 minus 9 is negative 7. So this is d. All right, so now let's find the sum. So the sum of the first 27 terms is equal to, let's take a look at our formula. So we can use this second one because we know n, we know how many terms are in, or we know the first term of the sum, we know how many elements are in the sum, and we know the difference. So 27 over 2 times 2 times the first term, which is 16, plus n minus 1, so 27 minus 1, times negative 7. Okay, so let's plug all this in our calculator. Okay, so the sum is negative 2025. Now this is asking us to find the sum of this arithmetic sequence. So they've told us that it's arithmetic. So we only need to look at one consecutive set of terms to find the difference. So the difference is 12. Okay, so we want to find the sum of the sequence. Sorry. But we don't know n. So what do we know? So we know we have these two formulas. We know the first term in the sequence. We know the last term in the sequence, which is 169. We also know d, but we don't know n. So in order to find n, what we can do is we can use this formula. Find the nth term in the sequence. We know that this is a1 plus n minus 1 times d. So we know the nth term in the sequence. The last term in the sequence is 169. We know the first term in the sequence is 13. We do not know n. And we know the difference, 12. So we can just solve this for n. So we'll go ahead and distribute the 12. We'll combine the like terms. Then we'll minus the 1. And we'll divide by 12. So in this case, n is 14. Okay, so now we know how many terms are in the sequence. So this question is asking us to find the sum. So let's use this formula because it's the simplest. So the 14th, the sum of the first 14 terms, so s sub 14 is equal to n, which is 14, times the first term plus the last term. So the first term was 13, I think. Plus the last term, which was 169, all divided by 2. So the sum of the first 14 terms of this sum is 1,274. So that's a brief introduction to arithmetic series. Next, we'll talk about geometric series.